Oh, hey everybody, how's it going? I'm just here chilling, doing my thing, bumping some Mac Dre, doing some AP physics problems, just chilling, keeping it real. Let's let's just go through this exam. I'm doing this because I don't want to do it in class because we really do need to move along with our pacing in AP. So, what I'm going to do is basically work out this whole entire exam that you had to do from beginning to end, and I'm going to begin with the multiple choice questions, and then I'll work through to the free response. So, keeping this in mind, I'm going to work these out fairly quickly. Okay, do keep that in mind, only because we're kind of at that stage of learning where these need to be fairly fast. So, for example, for question number 1, we want to know how high a projectile is going to go when we launch it. So, at this stage in the game, when we talk projectiles, it should be instinct to you that it's the sign component, that's the initial y speed, and that Vy at the top is going to be 0, and that we can just use the following formula to get the height. And since this is 0 and this is V naught squared sine squared theta, when we actually solve for y, you should be fairly comfortable getting answer C fairly quickly. And for question number 2, we have a sports car that's accelerating. It reaches 20 meters per second in 4 seconds. So let's be clear. Start some rest means V naught 0. V final is going to be 20 meters per second. We got a time of 3 seconds. And we want to know time of 4 seconds. We want to know how far it's gone. So lots of ways we could do this. Let's get the acceleration. That's going to be V minus V naught over T. I'm rearranging the equation V equals AT plus V naught, by the way, to get that. So that's going to be 20 minus 0 over 4. That's going to give me 5 meters per second squared. And so we can get our position as 1/2 AT squared plus 0 plus 0. That's the V naught T, and that's the X naught. So that's going to give us 1/2 times 5, and 4 squared is 16. So I'm going to get 8 times 5, so it looks like I'm getting 40 meters as my answer right there. So, all right. Now we want to know which of these shows the velocity as a function of time when we're slowing down at constant acceleration. That would be choice C, because we're going forwards. So this means forward velocity, and the negative slope means slowing down if we treat this as a velocity versus time graph. And then for number 4, this is your standard third law question. We got satellites in orbit around Earth. F1, so if I draw this as the satellite and this is Earth, we've got F1 is the force on the satellite from the Earth, F2 is the force on the Earth from the satellite. These two forces are third law pairs and should be exactly equal and opposite. And then we have this situation of the 3, 4, 5 triangle and the block. So let me just do a couple things right now, because I've done this kind of problem before. So let's just kind of be clear here that sine of theta is going to be 4 over 5, where 5 is the hypotenuse from Pythagoras' theorem. Cosine of theta is 3 over 5. I'm just going to write these down and leave them off to the side. And then what I'm going to do is we're being pulled up at constant velocity, and we want to know the force necessary to do that. And we'll assume that there's friction since it's given in the problem. So when I draw the free body diagram, let's be careful how we do this. We're going to have the pulling force, we'll have the normal force, we'll have the weight, and then we'll have the friction going this way, weight on the block due to the earth, normal on the block due to the plane, friction on the block due to the plane. And so what we're going to end up getting is that the pulling force minus the friction. And now we got to split this into components. So we'll have WBE cos theta and WBE times the sine of theta right here. Okay. So F minus mg sine theta equals 0. Now the friction force is mu times the normal force, which is going to be mu mg cos theta. So when we actually isolate the pulling force, this is what we're going to end up getting. So let's throw in our numbers and actually calculate. So we're going to have 3/10, which is mu, 0.3, times 50, times the cosine of theta, which is 3/5, plus 50 times the sine of theta, which is 4/5. So let's do a little bit of simplification here. This is, so that's 5, 50 divided times 5, cancels the other 5 here, so I get 9 plus 40. That's giving me 49 newtons worth of force. All right, so that's questions 1 through 5. In the next video, we'll take a look at questions 6 through 10.